In the spring air of 1879, in the quiet German city of Ulm, a child was born who would one day transform the way humanity understands reality itself. His name was Albert Einstein. The story of this boy does not begin with brilliance or acclaim but with wonder. The kind of deep, silent curiosity that stirs in the heart of a child who sees the world not as it is told, but as it truly appears. From his earliest days, Einstein was not fascinated by toys or games, he was captivated by mysteries. He looked at the world around him and saw questions hidden in every shadow, every flicker of light, every movement of the stars. It is said that when Einstein was around 5 years old, his father, Hermann Einstein, showed him something that would ignite his imagination for life: a small, simple compass. The boy held it in his hands and watched in awe as the needle pointed steadily north, no matter how he turned it. There was no visible connection, no thread or force that he could see, yet the needle obeyed an invisible command. It was a moment of silent revelation. Young Albert could not stop thinking about that unseen force that guided the needle. Something was there, something hidden, powerful, and constant. And though invisible, it was real. That thought would never leave him. To most children, the compass might have been a novelty. To Einstein, it was a key to the universe. That moment planted a seed, a question that would grow into the very foundation of his genius. What governs the invisible forces of nature? It was not knowledge that drove him, it was curiosity, pure, untamed curiosity. Years later, he would recall that event as one of the most formative experiences of his childhood, the spark that opened his eyes to the mysteries of physics. Einstein's early years were not marked by academic brilliance. In fact, his teachers considered him slow. He often sat quietly, lost in thought, refusing to answer questions the way others did. But his silence was not ignorance, it was reflection. While others memorized facts, he searched for meaning. His mother, Pauline, nurtured his sensitivity and love for music, especially the violin, which became his emotional companion for life. His father, an engineer, exposed him to the world of electricity and magnetism, fields still in their infancy at the time. Together, these influences formed a unique balance in young Albert's mind: sensitivity and logic, imagination and reason. By the age of 10, he had begun to think in pictures. Einstein's mind worked not through words or numbers, but through images. He would visualize complex scenarios, light beams, falling bodies, moving trains, and explore them in his imagination. This ability to think visually would later become one of his greatest tools. Long before equations, there were daydreams, and it was in those daydreams that relativity was born. In school, however, imagination was not valued. Teachers demanded obedience and rote learning, something Einstein could never accept. He questioned authority and challenged methods that valued repetition over understanding. Once, when asked by a teacher why he wouldn't simply memorize the lessons, he replied, "Because I want to understand nature, not the words in your book." It was this defiance, this refusal to surrender his curiosity to conformity, that set him apart from the rest. At home, his uncle Jacob, a mathematician and engineer, introduced him to algebra and geometry. But instead of simply teaching him formulas, Jacob encouraged Albert to think about what mathematics represented: patterns, relationships, and the invisible harmony of the universe. Einstein was fascinated. Numbers to him were not mere symbols, they were the language of creation. He once said that mathematics possessed a mysterious beauty, a purity that could express the very structure of reality. But life was not easy. When his father's business failed, the family moved to Munich and later to Italy. The young Einstein struggled with the rigid education system, which valued discipline over curiosity. He found solace in books, especially those about natural science and philosophy. He devoured works by Immanuel Kant and Ernst Mach, and he began to question not only how the universe worked, but why it worked that way. These readings would later shape his philosophical approach to science, an approach that saw the universe not as a machine, but as a living system bound by elegance and logic. At 16, Einstein experienced another turning point. As he stared out the window one afternoon, he imagined what it would be like to ride alongside a beam of light. That single thought, a young boy chasing light, became one of the most famous thought experiments in history. In his mind, he saw the waves of light standing still beside him, frozen, something that contradicted every known law of physics at the time. That paradox would haunt him for years and eventually lead him to the discovery of relativity. These moments of imagination were not idle fantasies. For Einstein, imagination was the laboratory of truth. He once said, "Imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world." This belief guided him throughout his life. Long before he had the tools or the equations, he had the questions, and the courage to follow them wherever they led. As the family moved again, Einstein enrolled in a school in Aarau, Switzerland. Unlike the rigid institutions of Germany, Aarau encouraged independent thought. It was here that Einstein began to flourish academically. He thrived in an environment that valued creativity and critical reasoning. He spent hours contemplating the nature of light, motion, and time. At night, he would gaze at the stars, lost in the silent music of the cosmos, wondering what hidden rules orchestrated their eternal dance. In his early essays, written before he even entered university, Einstein explored the principles of space and energy with astonishing insight. He questioned whether time was absolute or if it changed depending on the observer. Though these were only youthful speculations, they foreshadowed the revolution that would later define his legacy. His curiosity had evolved from simple wonder into profound scientific inquiry. Einstein's relationship with learning remained unique. He distrusted authority, disliked examinations, and preferred learning through intuition rather than instruction. To him, the classroom was too narrow for the vastness of thought. He once remarked that, "The only thing that interferes with my learning is my education." Yet, in this apparent rebellion lay a deeper truth, that true discovery is born not from obedience, but from independence of mind. The compass that fascinated him as a boy had grown into a lifelong obsession with the invisible. He wanted to understand what lay behind appearances, the hidden forces that moved stars, guided atoms, and bent light. This relentless pursuit of the unseen would shape the rest of his life. By his late teens, Einstein's fascination with physics had matured into a clear sense of purpose. He dreamed of a universe governed not by chaos, but by harmony, a universe where beauty and simplicity ruled the laws of nature. He began to see patterns in the way energy flowed, light behaved, and gravity pulled. The universe to him was not random but elegantly structured, like a symphony whose music could be understood through reason and imagination. But behind his growing genius, there was always the same quiet child, the one who stared at a compass and asked why. The same child who wondered what it meant to chase light. The same child who believed that every mystery could be understood, if one only dared to ask the right question. Einstein's early years were not just the story of a student learning science, they were the story of a soul awakening to the beauty of truth. Every discovery he would later make, relativity, photoelectric effect, mass energy equivalence, all traced their origins back to those early questions. The world saw him as a genius, but Einstein saw himself as a lifelong student of the universe, still trying to understand the simple wonder that had first captivated him. His childhood was a testament to the power of curiosity. It showed that greatness is not born in brilliance alone, but in the courage to ask what others ignore. The compass, the light, the stars, these were not just images from a boy's imagination. They were symbols of a mind that refused to accept limits. Einstein's early curiosity was not a momentary phase but a lifelong condition. It was his constant companion, his driving force, and his sanctuary. Even when the world doubted him, even when teachers scolded him for daydreaming, he never let go of that inner flame. It was curiosity that guided him, comforted him, and eventually defined him. In those quiet moments of his youth, when he questioned the invisible, Einstein unknowingly began a revolution, not only in science but in human thought itself. He proved that the greatest discoveries are born not in laboratories, but in the imagination. The true journey of understanding the universe begins not with what we know, but with the courage to wonder about what we don't. The world around young Albert Einstein was changing rapidly, yet his mind seemed to live on a different timeline altogether. While society rushed toward progress through machines and industry, he lingered in silence, seeking the deeper rhythm beneath the noise. Even as a teenager, he felt that the universe spoke a hidden language, a language that revealed itself only to those who could listen beyond the surface. For Einstein, that language was nature's order, a whisper of symmetry and mystery carried through light, magnetism, and motion. At 17, when most young men were just beginning to define their ambitions, Einstein was already consumed by questions that stretched beyond the boundaries of textbooks. He would walk for hours alone, lost in thought, pondering why the speed of light seemed absolute, or how time could differ for two observers in motion. These were not the idle musings of youth. They were the seeds of a revolution waiting patiently to bloom. He once said that his imagination became his most faithful companion. Whenever he faced confusion or doubt, he would retreat into that private world of thought experiments. Worlds built not of matter but of ideas. In those formative years, Einstein's rebellion against rigid systems became even more pronounced. He found school oppressive, its strict routines suffocating to a mind that thrived on freedom. He despised blind obedience and rote learning, considering them enemies of true understanding. When a teacher once told him that he would never amount to anything because he refused to follow rules, Einstein quietly smiled, knowing that the universe itself obeyed no authority but its own laws. That moment became symbolic of his life, a refusal to conform, not out of arrogance, but out of devotion to truth. His move to Zurich to attend the Swiss Federal Polytechnic marked a new chapter in his awakening. It was there, among diverse minds and ideas, that Einstein began to shape his intellectual identity. Though he struggled with formal lectures, he excelled in independent thought. While others memorized theories, he challenged their foundations. He loved discussions that bridged science and philosophy, often spending late nights debating with classmates about the nature of reality. To Einstein, physics was not just a discipline, it was a dialogue with the universe. At this time, he was deeply influenced by two guiding lights, James Clerk Maxwell and Isaac Newton. Maxwell's equations, describing the behavior of electricity and magnetism, filled him with awe. They hinted that light itself was an electromagnetic wave, yet something about them puzzled him. If light were a wave, what was it waving through? The idea of an ether seemed unsatisfactory to him, a concept that existed only to fill a gap in understanding. He began to suspect that light and motion might follow principles far more elegant and universal than anyone had realized. These early reflections would later explode into the theory of relativity. Einstein's curiosity was not limited to science alone. He was equally fascinated by music and philosophy, two realms that spoke to the emotional and ethical dimensions of his mind. Playing the violin gave him solace during times of frustration. He described music as an expression of cosmic harmony, where mathematical precision met emotional truth. This blending of art and science shaped his approach to physics. To him, a great theory had to be not only correct but beautiful. Beauty, simplicity, and truth were inseparable. By his early 20s, Einstein's path was anything but easy. After graduating in 1900, he struggled to find work. His independence and disregard for authority had not impressed his professors, who refused to recommend him for academic positions. Yet even in rejection, he found strength. He took a modest job at the Swiss Patent Office in Bern, an ordinary position that would paradoxically become the birthplace of extraordinary ideas. The daily routine of reviewing inventions gave him time to think deeply, to dream, and to explore physics from fresh perspectives. In that small, unremarkable office, surrounded by papers and silence, Einstein's curiosity found space to grow without boundaries. He began to develop what he later called thought experiments, mental scenarios where he tested the laws of physics through imagination rather than apparatus. What if one could travel on a beam of light? What would one see? Would time slow down or stop altogether? These questions, pursued with quiet intensity, led to insights that would eventually rewrite the structure of space and time. But before those breakthroughs, Einstein endured a long journey of solitude and introspection. Many dismissed his ideas as impractical or naive, yet he remained steadfast. His conviction that the universe must follow rational, elegant principles gave him the strength to persevere. He believed that nature's mysteries could be unlocked not by authority, but by relentless curiosity guided by reason. The compass that had once captivated him as a child remained symbolic throughout his life. It represented the invisible forces that govern reality, fields, energies, interactions beyond sight. Decades later, when he formulated the concept of spacetime curvature in general relativity, that same fascination with invisible forces would find its ultimate expression. What began as a child's wonder at a magnetic needle evolved into a vision of gravity not as a force at all, but as the geometry of the universe itself. Einstein's early curiosity also reflected a moral dimension. He was not content merely to understand the physical world, he wanted to grasp its meaning. As he matured, he began to see science as a bridge between the human spirit and the cosmos. He wrote that the most beautiful experience one can have is the mysterious, a feeling that lies at the heart of all true art and science. This awe before mystery, this reverence for the unknown, shaped his worldview. To him, curiosity was sacred. It was the purest expression of human dignity. By the time Einstein published his 4 groundbreaking papers in 1905, he was no longer just a thinker, but a visionary whose early wonder had matured into world-changing insight. The same questions that had stirred his young imagination now crystallized into precise theories: light's dual nature, the equivalence of mass and energy, and the relativity of space and time. Every one of these ideas could trace its lineage back to the quiet, curious child of Ulm who once stared at a compass. His curiosity was never satisfied, and perhaps that was its power. Each discovery only opened new doors, each answer revealed deeper questions. Even after global fame, Einstein remained humble before the universe. He would often say that he still felt like a child playing on the seashore, finding a smoother pebble or a prettier shell, while the great ocean of truth lay undiscovered before him. This humility was born from the same curiosity that had guided his every step. Einstein's early fascination with invisible forces would eventually extend beyond physics into his understanding of humanity itself. He saw patterns in the social world that mirrored those of nature: unity amid diversity, order emerging from chaos. He believed that curiosity should lead not only to scientific progress but to compassion, for to understand the universe is to recognize our shared existence within it. His scientific imagination and moral imagination were one and the same. Looking back, it becomes clear that Einstein's genius was not simply the result of intellect, but of perspective. He saw the world differently because he felt it differently. Where others saw facts, he saw patterns. Where others saw equations, he saw relationships. His mind could move fluidly between logic and intuition, calculation and wonder. This harmony of opposites, the scientist and the dreamer, the rebel and the philosopher, made him who he was. The early chapters of Einstein's life remind us that genius often begins in stillness, in the quiet observation of the ordinary. A compass, a ray of light, a melody on a violin, these became portals into infinity. Einstein's curiosity transformed simple experiences into profound insight, and perhaps that is the greatest lesson his story offers: that the universe does not reveal its secrets to those who rush to answers, but to those who linger in the questions. In later years, when journalists and students asked him how he discovered relativity, he would smile and say, "By thinking, not by special knowledge." It was an answer that puzzled many, but captured the essence of his journey. He had never stopped thinking like that curious boy who saw wonder in the unseen. Einstein's story, especially his early curiosity, transcends science. It speaks to something deeply human, the desire to understand, to connect, to see beyond the surface. His life reminds us that curiosity is not a childish trait to be outgrown, but the very foundation of creativity and progress. Without it, there can be no discovery, no art, no advancement. In the vast narrative of human history, few minds have reached as far or as deeply as Einstein's. Yet when stripped of fame and formula, what remains most remarkable about him is not his genius, but his childlike wonder. The same wonder that led him to ask questions that others never thought to ask. That is the legacy of his curiosity, the courage to imagine the impossible, and the patience to pursue it until it becomes truth. And so, the story circles back to where it began: a child, a compass, and an invisible force. That moment, in the quiet light of a German home, contained the seed of everything that was to come: the equations, the revolutions, the reshaping of time and space. It was the spark that ignited one of the greatest minds in history. Through that spark, Einstein taught humanity a timeless lesson that curiosity is the most powerful force in the universe. Stronger than gravity, faster than light, and eternal in its reach. It is the invisible thread that connects the mind of a child to the mysteries of the cosmos, the same thread that once guided a tiny compass needle north and, in doing so, pointed Albert Einstein toward the infinite. In the early years of the 20th century, the world stood at the edge of transformation. Machines roared through the streets, telegraphs connected continents, and electric lights began to banish the darkness of night. Humanity was confident, believing that it had mastered nature through reason and progress. The laws of Isaac Newton, written more than 2 centuries earlier, seemed unshakable, describing a universe of precision and certainty. Yet somewhere in a modest apartment in Bern, Switzerland, a quiet man was preparing to challenge everything the world thought it knew about reality itself. His name was Albert Einstein, and his mind was about to bend the very fabric of existence. Einstein was no longer the curious boy lost in thought. He had become a man of deep contemplation, guided by the same fire that once lit up his childhood eyes. Working at the Swiss Patent Office, he spent his days reviewing inventions and his nights wrestling with the mysteries of light, motion, and time. To the outside world, he appeared ordinary, a clerk in a gray suit, immersed in routine paperwork. But behind those calm eyes, the universe was being rearranged. Einstein's imagination had become a laboratory of ideas, and in that mental laboratory, the old pillars of science began to crumble. He was obsessed with a single question that had haunted him since youth. What would it be like to travel alongside a beam of light? It was a simple, almost poetic thought, yet its implications were vast. According to classical physics, light should behave like any other wave, affected by the motion of the observer. But experiments had shown otherwise. No matter how fast one moved, light always traveled at the same speed. This paradox struck at the heart of Newtonian mechanics, which assumed that time and space were absolute, the same for everyone, everywhere. Einstein dared to ask what if they weren't. As he pondered this, an idea began to take shape, an idea that would soon shake the foundations of science. In 1905, at the age of 26, Einstein published 4 papers that would later be known as the Annus Mirabilis papers, the miracle year of physics. Among them was the paper that introduced the special theory of relativity. Its premise was revolutionary. The laws of physics are the same for all observers, and the speed of light in a vacuum is constant for everyone, regardless of motion. From these 2 simple postulates, Einstein derived consequences so extraordinary that they redefined reality itself. Time, he realized, does not flow uniformly like a clock ticking in the heavens. It bends and stretches depending on speed. The faster you move, the slower time passes for you. Space, too, is not fixed. It contracts as you approach the speed of light. The universe, it turned out, was not a rigid stage on which events occurred, but a living, dynamic fabric. woven together by space and time into a single continuum spacetime. For the first time, humanity saw that the universe was not as Newton had described, an unchanging grid with absolute time and space, but a flexible structure that responded to motion and energy. What had once seemed intuitive now appeared illusory. Simultaneity, for example, was no longer absolute. Two events that appear simultaneous to one observer might occur at different times for another. The very notion of now became relative. This revelation was more than a scientific breakthrough, it was a philosophical earthquake. It altered the way humans perceived existence itself. Einstein had shown that reality depended on perspective, that even time could not be separated from the observer. He had not just rewritten physics, he had rewritten the concept of truth. Yet Einstein's revolution did not stop there. In the same year, another of his papers introduced an equation that would become one of the most famous in history, eta miceti. With those 5 characters, he revealed a secret hidden within the fabric of the universe, that energy and mass are interchangeable. Matter, he showed, is simply condensed energy. The entire cosmos, from the smallest atom to the largest star, is an interplay of these two forms, constantly transforming but never vanishing. This simple yet profound equation bridged 2 realms of existence that had always seemed separate, the tangible world of matter and the radiant world of light. It implied that the energy of the stars, the fire of the sun, and the structure of the universe itself were all part of one grand design. Later generations would use this principle to unlock the power of the atom, for better and for worse. But for Einstein, the beauty of the equation lay not in its utility, but in its elegance, its perfect symmetry. As the scientific world began to take notice of these radical ideas, confusion and controversy followed. How could time slow down? How could mass increase with speed? To many, Einstein's concepts defied common sense. Yet experiment after experiment confirmed his predictions. Nature herself seemed to obey this quiet man's vision. Slowly the world began to understand that a new era of physics had begun. Still, Einstein was restless. Though his special theory of relativity described how motion affected space and time, it left one great force unexplained: gravity. Newton had described gravity as a force pulling objects toward one another, a mysterious action at a distance. But Einstein felt there had to be something deeper, something geometric and elegant behind it. Over the next decade, he embarked on a quest that would push his mind to its limits, a quest to unify motion, light, and gravity under a single framework. He began to imagine space not as emptiness, but as a flexible fabric that could bend and curve. He envisioned planets and stars not being pulled by gravity, but moving along the curved paths created by massive bodies. Space, he thought, tells matter how to move, and matter tells space how to curve. It was a breathtakingly new way to see the cosmos. The mathematical challenge was immense. For years, Einstein wrestled with equations, sometimes working day and night, pacing across his study as he scribbled ideas on scraps of paper. His friends and colleagues thought he was chasing an impossible dream, but Einstein's mind was relentless. He believed that nature's laws must be beautiful, consistent, and harmonious, and he refused to stop until he found that harmony. Finally, in 1915, after years of struggle, Einstein unveiled his masterpiece, the general theory of relativity. In it, he replaced Newton's invisible force with the concept of spacetime curvature. Massive objects like stars and planets deform the fabric of space and time around them, and smaller objects simply follow the curves of that geometry. Gravity, therefore, was not a force but a consequence of the universe's structure. The idea was revolutionary, and at first many doubted it, but then came the proof. In 1919, during a total solar eclipse, astronomers observed that starlight passing near the sun was bent exactly as Einstein's equations predicted. The news spread around the globe, and overnight, Einstein became a legend. Newspapers proclaimed "Light's all ascadeliantes," declaring that Newton's universe had been dethroned. The impact of Einstein's theories reached far beyond science. Philosophers, poets, and ordinary people were captivated by his vision of a universe where space could bend, time could flow differently, and matter and energy danced together in cosmic unity. His ideas inspired not only physics but art, literature, and culture, marking the birth of the modern age. Yet behind this intellectual triumph lay the same essence that had always driven him: curiosity. Einstein never saw himself as a genius in pursuit of fame. He often said that he was simply, passionately curious. His discoveries were not born from ambition, but from an almost spiritual hunger to understand how the universe works. For him, each equation was a prayer, each insight a glimpse of something divine. Even as his fame grew, Einstein remained humble before the mysteries of creation. He once wrote that the most incomprehensible thing about the universe is that it is comprehensible. To him, the fact that human thought could grasp cosmic laws was itself a miracle, evidence that the human mind was somehow aligned with the order of the cosmos. Through relativity, Einstein revealed that reality is not absolute but relational. Everything depends on the observer's frame of reference. This insight went beyond physics, it reshaped philosophy, and even human consciousness. It reminded humanity that truth is not always singular, that perspective matters, and that understanding the universe requires both logic and empathy. As the 20th century advanced, Einstein's theories became the foundation of modern physics, guiding everything from the understanding of black holes to the expansion of the cosmos. His ideas laid the groundwork for technologies like GPS, nuclear energy, and space exploration, innovations he never sought, yet made possible through his pursuit of knowledge. And through it all, he remained that same quiet thinker. The man who once wondered at a compass needle, who imagined chasing light, and who refused to accept the obvious as truth. His revolutionary ideas were not the product of calculation alone, they were the flowering of imagination. Einstein saw the world not as a fixed machine, but as a living symphony of energy and motion. In that sense, his theories were not just scientific, they were poetic. They captured the universe's elegance. The interplay of time and space, the dance of matter and light, the geometry of existence itself. Einstein did not simply describe the cosmos, he illuminated it, revealing its hidden structure and its profound beauty. When the announcement of Einstein's theory of general relativity spread across the world in 1919, the age of certainty was over. Newspapers called him a second Copernicus, the man who had once again moved the earth from the center of understanding. Yet in the quiet of his study, Einstein did not celebrate. He sat by his window, pipe in hand, watching the light bend gently through the glass. To him, the eclipse had not proven his greatness, it had proven that nature itself was elegant beyond imagination. He felt gratitude, not triumph, for being allowed to glimpse a pattern so profound. As the scientific community absorbed the shock of relativity, the universe itself seemed to expand. Concepts that had once been absolute dissolved into a fluid continuum of perspectives. Time was no longer a universal clock, space was no longer an empty stage. Every star, every planet, every beam of light participated in the same grand curvature, shaping and being shaped in return. The cosmos was alive with geometry. It was as if the universe, once thought mechanical, had revealed its artistry. Einstein's equations were unlike any that had come before. They described how matter tells space how to curve, and how curved space tells matter how to move. Gravity, that ancient mystery, was no longer a force pulling through emptiness, but a manifestation of form. The simplicity of the idea concealed its depth. Few could truly grasp the mathematics, but all could feel the wonder. The thought that reality itself could bend, that light could follow invisible arcs across the sky, captured the imagination of an entire generation. Einstein's revolution extended far beyond the boundaries of laboratories. It reached philosophers who questioned the nature of truth. It reached artists who began to see form and perspective in new ways. Even musicians drew inspiration from the fluidity of time. The modern world began to mirror the relativity of existence, embracing movement, change, and uncertainty. It was as if Einstein had not only rewritten physics, but had subtly shifted humanity's perception of reality itself. But for Einstein, the journey was not over. The deeper he gazed into his equations, the more mysteries they revealed. One of them suggested that the universe could not be static, that space might be expanding or contracting. This troubled him. At the time, astronomers believed in a steady, eternal cosmos, and so Einstein introduced what he called the cosmological constant, a term that would keep the universe in balance. Years later, when Edwin Hubble discovered that galaxies were indeed moving apart, Einstein called that constant the greatest blunder of my life. Yet even in that so-called mistake lay a sign of genius, the humility to admit error and the courage to correct it. The implications of his theories soon reached unimaginable scales. In the warped geometry of spacetime, scientists found the possibility of black holes, regions where gravity becomes so intense that not even light can escape. Einstein himself was skeptical of such extremes, but his equations whispered of their existence nonetheless. Decades later, those whispers would become cosmic reality. Each new discovery confirmed that the framework he built was vast enough to contain wonders he had never imagined. As the decades unfolded, relativity became the compass by which humanity navigated the cosmos. Astronomers measured the bending of light from distant stars, physicists traced the slow ticking of time near massive bodies, and engineers quietly wove his equations into the technologies that guide airplanes and satellites. Every GPS signal that reaches a traveler's phone carries a correction derived from Einstein's insight, a silent tribute to the man who redefined motion itself. Yet amid the glory and global recognition, Einstein remained, in spirit, the same quiet observer. Fame surrounded him like a storm, but he drifted gently through it, more interested in thought than in applause. He spoke softly, smiled kindly, and turned every question about his genius into a reflection on curiosity. "I have no special talent," he often said. "I am only passionately curious." It was that passion, not intellect alone, that allowed him to reimagine the universe. Relativity also redefined humanity's relationship with time itself. Before Einstein, time was imagined as a river that flowed steadily forward, the same for everyone. After Einstein, time became personal, an elastic dimension interwoven with space. Every clock, every heartbeat, every ray of light carried its own rhythm. Two observers could live the same event and age differently. In this realization lay both beauty and melancholy, the acknowledgement that the passage of time is not universal, but intimate, unique to each path through space-time. Philosophers saw in this the echo of a deeper truth, that existence is not fixed, that reality depends on the observer. Einstein had not only transformed physics, but had given language to subjectivity itself. The modern world, grappling with uncertainty, mirrored this insight. The rigid structures of the past gave way to fluid interpretations in art, literature, and culture. The very idea of perspective, that truth could depend on where you stand, became a defining theme of the 20th century. Einstein, however, sought something even more profound. He wanted unity. He dreamed of a single set of equations that would bind all the forces of nature, gravity, electromagnetism, and eventually the emerging quantum theory, into one grand harmony. For the last 30 years of his life, he pursued this dream tirelessly, filling notebooks with attempts to reconcile the large and the small, the cosmic and the atomic. Though he never succeeded, his quest itself became a symbol of humanity's eternal search for order within chaos. His relationship with quantum physics revealed the philosopher within him. The new generation of physicists, led by Niels Bohr, saw the subatomic world as a realm of probabilities where uncertainty ruled. Einstein admired their brilliance but could not accept their conclusions. "God does not play dice with the universe," he famously declared. To him, the universe was too elegant, too coherent, to be governed by chance. This debate between Einstein and the quantum pioneers became one of the most profound dialogues in the history of science. Not merely a clash of theories, but a conversation about the nature of reality itself. Even as he aged, Einstein's mind remained luminous. Visitors to his Princeton home found him surrounded by papers, violin resting nearby, his white hair haloed by the afternoon light. He spoke of the cosmos as one speaks of a beloved, with reverence and familiarity. When he explained relativity, he did not describe it as conquest but as discovery, as if he had uncovered a truth that had always been waiting patiently in the structure of existence. In the years that followed, the practical applications of his work expanded far beyond what he had ever intended. The equation E=mc dive, so graceful in its simplicity, became both the promise of new energy and the harbinger of destruction. The development of the atomic bomb, rooted partly in the understanding of mass-energy equivalence, weighed heavily on his conscience. Though he had not built the weapon, Einstein felt a moral responsibility for the knowledge that made it possible. He spent the rest of his life advocating for peace, warning humanity that its mastery of nature must be guided by wisdom. Through it all, the public continued to see in Einstein a symbol of intellect, but those who knew him saw something deeper, a man of profound empathy, humor, and humility. He treated everyone, from fellow scientists to school children, with the same gentle respect. When asked about his achievements, he would shrug and say, "I did not invent relativity, I merely found it. It was there all along." He believed that the laws of nature were timeless truths, waiting to be perceived by anyone curious enough to look. As time passed, Einstein's theories continued to unfold new meanings. Astronomers detected gravitational waves, ripples in spacetime caused by colliding black holes, exactly as he had predicted a century earlier. Each discovery was another echo of his insight, resonating through the fabric of science. The more humanity explored, the more it realized that Einstein had not just changed equations, he had expanded the boundaries of imagination. In the broader sense, his revolution was not confined to physics. It was a revolution of thought, of perception, of humility before the cosmos. He showed that certainty is an illusion, that the universe is not a clockwork of fixed laws, but a living, breathing continuum. He invited humanity to look beyond appearances, to question assumptions, and to see the interconnectedness of all things. Late in life, when asked what he hoped people would remember about him, Einstein smiled and said, "I want to know God's thoughts, the rest are details." To him, God was not a figure of religion but a metaphor for the underlying order of the universe, the harmony hidden beneath complexity. His search for those thoughts never ceased. Even on his final day, as he lay in the quiet of his Princeton hospital room, he continued to scribble equations on a piece of paper. When he could no longer speak, he whispered to a nurse in German, words she could not understand, perhaps fragments of the same cosmic conversation that had begun in his youth. Einstein's revolutionary ideas redefined more than physics. They redefined what it means to be human in a vast, mysterious universe. He revealed that we are participants, not spectators, woven into the same space-time we observe. Every step, every breath, every second of existence bends the fabric of reality in subtle ways. The cosmos is not separate from us, we are expressions of it, conscious fragments of its infinite unfolding. The story of his discoveries is therefore not merely a scientific chronicle, but a testament to the power of curiosity and imagination. It reminds us that the universe yields its secrets not to those who demand them, but to those who listen with wonder. Einstein listened, not with instruments, but with the music of thought. He heard in the equations the rhythm of creation and shared it with the world. As the camera of history pans outward, beyond the quiet rooms and chalk-stained boards where he once worked, it finds a universe still glowing with his influence. Satellites orbit in paths predicted by his geometry. Light from distant galaxies bends gracefully through the void, echoing his curvature of space. The ticking of atomic clocks corrects itself in obedience to his relativity. Even now, each sunrise carries within it the interplay of energy and matter that his equations unveiled. And yet, perhaps the most enduring legacy of Einstein's revolution is not the science itself, but the spirit behind it. the belief that knowledge and wonder must walk hand in hand. He showed that understanding the universe is not an act of domination, but of communion. The cosmos, in all its vastness, is approachable through the human mind, not because we are powerful, but because we are curious. In the end, Einstein's life was a circle that closed where it began, with the same question that stirred in a child holding a compass: what invisible order moves the world? His answer, written in the language of relativity, revealed that the answer lies not in separation but in connection, not in certainty but in curiosity. The universe, he taught, is a web of relationships between light and gravity, space and time, matter and energy, thought and being. And so the story of his revolutionary ideas becomes ultimately a story of unity, of how one mind, guided by wonder, wove together the threads of existence into a vision that still shapes the future. Through Einstein, humanity learned that to redefine the universe is to rediscover itself, fragile, brilliant, and forever reaching toward the stars. At the dawn of the 20th century, the world stood on the edge of transformation. Cities were glowing with electric lights. Factories were echoing with the hum of machines, and the modern age was awakening. Yet beneath the surface of this industrial progress, a quiet revolution was beginning, one that would not change tools or technology first, but the very way humanity understood reality itself. It would start not in a laboratory filled with instruments, but in the mind of a man sitting at a desk, surrounded by papers and dreams. Albert Einstein. The year was 1905, a year that would later be called Einstein's miracle year. He was not a famous scientist then, nor did he hold a university position. He worked as a clerk at the Swiss Patent Office in Bern, reviewing applications for electrical devices. To most, it was a dull, repetitive job. But to Einstein, it was freedom to think, to imagine, to question everything that science had accepted as truth. Each evening, after the day's paperwork was done, he would sit in his small apartment, a cup of coffee by his side, his mind traveling far beyond the confines of his desk. It was during those solitary nights that he began to challenge one of the most deeply held beliefs in physics, the idea that time and space were absolute. For centuries, scientists had trusted the framework laid down by Isaac Newton, a universe of precision, order, and certainty. Time ticked the same for everyone, everywhere. Space was a stage upon which events unfolded, never changing, never bending. The laws of motion were solid, the mechanics of the heavens predictable. It was a comforting vision of reality, one that had guided humanity for over 200 years. But Einstein, with his restless curiosity, sensed something missing. He wondered, what would happen if someone could travel close to the speed of light? Would time still flow the same? Would space remain unchanged? These were questions no one had dared to ask, for they seemed beyond the reach of experiment or reason. Yet Einstein had a weapon no laboratory could match: imagination. He often described his thoughts as Gedanken experiment, or thought experiments. In his mind, he could chase a beam of light across the universe, ride upon it, and see what the laws of nature would reveal. One evening, as he envisioned himself moving alongside a ray of light, he realized that from such a perspective, the light would appear motionless, frozen in place. But according to all known laws of physics, that was impossible. Light, he knew, always moved at a constant speed, no matter how fast you tried to catch it. This contradiction burned in his mind. There had to be a deeper truth, something that connected the observer and the observed, motion and perception, time and space. Then, in a moment of profound insight, the answer came. Perhaps time and space themselves were not fixed at all. Perhaps they were relative, depending on how one moved through the universe. It was a simple idea, yet so radical that it shattered centuries of certainty. The speed of light, he concluded, was the only absolute. Everything else, distance, time, even simultaneity, was flexible, bending to the motion of the observer. That summer, Einstein published 4 papers in the Annalen der Physik, one of the leading scientific journals of the time. The last of them, titled On the Electrodynamics of Moving Bodies, introduced what would become known as the special theory of relativity. In it, he presented two simple postulates. First, that the laws of physics are the same for all observers moving at constant speed, and second, that the speed of light in a vacuum is the same for everyone, regardless of their motion. From these principles, he built a universe where time dilated, lengths contracted, and simultaneity dissolved. To the scientific establishment, it was as if someone had pulled the ground out from under their feet. Time, the most familiar dimension of human experience, was no longer universal. Two observers could witness the same event and disagree on when it happened, and both would be correct. Space, too, was not a passive backdrop but an active participant in the dance of reality. The distinction between past, present, and future became a matter of perspective, not absolute truth. But the true power of Einstein's theory came from its elegance. From just a few assumptions, he derived relationships that explained phenomena that had puzzled physicists for decades. One of these was the mysterious link between energy and mass, a relationship he expressed in the now legendary equation E=mc². This simple formula revealed that energy and matter were two sides of the same coin, interchangeable under the right conditions. It meant that a small amount of matter could release an immense amount of energy, a concept that would one day change the course of human history. At first, few scientists understood his work. It was too abstract, too far removed from the everyday experiences of the laboratory. Some dismissed it as philosophy rather than physics. But over time the evidence began to accumulate. Observations of subatomic particles, of light traveling through moving systems, and later, of atomic behavior, all confirmed the predictions of relativity. The universe that once seemed static and mechanical now appeared dynamic and interconnected. Einstein's life began to change. He left the patent office and joined academia, his name spreading through the scientific community like wildfire. By 1915, he had taken his ideas further, developing what he called the general theory of relativity, a theory that extended his principles to include gravity. He imagined space and time as a vast fabric, capable of bending and stretching under the influence of mass and energy. Planets did not orbit because of invisible forces pulling on them, but because they followed the curves in spacetime created by massive bodies like the Sun. Gravity was geometry. This idea, once again, was revolutionary. To test it, Einstein proposed an experiment during a solar eclipse. Starlight passing near the Sun should bend slightly, its path curved by the Sun's gravity. In 1919, British astronomer Arthur Eddington led an expedition to observe the eclipse. When the results came in, they matched Einstein's predictions perfectly. The news spread around the world. "Light all askew in the heavens," declared the New York Times. Overnight, Einstein became a global icon, the face of genius, the man who had rewritten the universe. But fame did not distract him from the profound implications of what he had discovered. Relativity was more than a scientific theory, it was a philosophical revolution. It taught humanity that perspective matters, that reality is not singular but woven from countless viewpoints. It showed that truth, even in the cosmos, is relational, a tapestry of motion and observation. It also redefined humanity's sense of place in the universe. No longer was the cosmos a rigid stage on which we acted, it was a living, breathing entity, shaped and reshaped by everything within it. For Einstein, the theory's beauty lay in its simplicity. He often said that nature is subtle but not malicious, that its truths are accessible to those who seek them with clarity and humility. His relativity was not an attempt to complicate physics, but to simplify it, to show that the laws of the universe, no matter how strange, were built on harmony and logic. In his eyes, the cosmos was not chaos but music, a silent symphony of light, energy, and motion. The impact of relativity rippled far beyond science. Artists began to explore new dimensions of perspective and abstraction, inspired by the relativity of space and time. Philosophers debated the implications for free will, causality, and existence. Even literature and film began to reflect the fluidity of time, from the fractured narratives of modernism to the timeless paradoxes of cinema. Einstein's vision had transcended the laboratory, it had entered the human imagination. Yet Einstein himself remained deeply humble. He once said, "I am satisfied with the mystery of life and the awareness of the marvelous structure of existence." To him, relativity was not an achievement but a discovery, a glimpse of something eternal. He was, in his own words, a deeply religious non-believer, seeing in the order of the universe a reflection of something beyond comprehension. But even as the world celebrated his triumph, Einstein knew that the theory of relativity was only the beginning. The universe, he believed, was far richer and stranger than even his equations could describe. He continued to search for deeper unity, for a single theory that would explain all the forces of nature. He pursued this dream until his final days, his desk covered in scribbled formulas, his mind still wandering through the curvature of space-time. The birth of relativity marked the birth of modern physics, a transition from the clockwork universe of Newton to the flexible, interconnected cosmos of Einstein. It changed how humanity measures time, how it navigates the stars, and even how it contemplates existence. It is the reason satellites can guide travelers, the reason atomic clocks remain precise, the reason we can map galaxies billions of light years away. Einstein's equations are not just written on paper, they are written in the structure of reality itself. As the story of relativity unfolded, it became clear that Einstein's genius was not only in his intellect, but in his vision. The ability to see simplicity in complexity, order in mystery. He had given the world more than formulas, he had given it a new way to dream. The idea that space and time are not boundaries but dimensions of freedom continues to inspire every scientist who dares to ask, "What if?" And so, the theory of relativity was not merely born, it was awakened. It was a whisper from the universe itself, speaking through the mind of one man who listened closely enough to hear. In that whisper was a truth both humbling and liberating, that the cosmos is not fixed, that everything moves, everything flows, and that even time itself can stretch and breathe. Through Einstein, humanity learned that to understand the universe is not to control it, but to be in awe of it, endlessly, beautifully, relativity. As the echoes of Einstein's revelation spread through the early 20th century, the world began to change in ways no one could have predicted. The theory of relativity was no longer just a collection of equations in a journal, it was the foundation of a new era, an era where humanity's understanding of the universe expanded beyond imagination. It was as if Einstein had opened a hidden door in the fabric of existence, and through it, light poured in, revealing a cosmos alive with curvature, motion, and mystery. Einstein himself, however, was far from the image of a triumphant hero. Fame followed him relentlessly, but he wore it like an ill-fitting coat. He continued to walk through the streets of Berlin with his violin tucked under his arm, lost in thought. Reporters called him the new Newton, the man who dethroned absolute space and time. Yet Einstein never saw himself as a conqueror of truth, only as its humble servant. "The most beautiful experience we can have," he once said, "is the mysterious. It is the fundamental emotion that stands at the cradle of true science." The birth of relativity was not just a scientific moment, it was a cultural awakening. The certainty of the old world, of absolute order, of fixed truths, began to dissolve. Artists like Picasso and Dali found in Einstein's ideas a mirror of their own explorations of perspective and time. Philosophers grappled with the implications of a reality that shifted with the observer. Even poets began to weave the language of relativity into their verses, seeking to express the fluid nature of existence. The universe, once thought mechanical, now appeared almost poetic. But while the public marveled at the poetry of his vision, Einstein saw a universe of precise structure, a geometry of space and time that obeyed the deepest logic of nature. The bending of starlight, the slowing of time near massive bodies, the expansion of space itself, these were not abstractions to him. They were the handwriting of the cosmos. Each phenomenon confirmed that his equations were not inventions but discoveries, reflections of a truth that had always been there, waiting for humanity to see. As telescopes grew more powerful and technology advanced, Einstein's predictions began to take shape in the physical world. In the 1920s and 1930s, astronomers began to measure the expansion of the universe, confirming what his equations had quietly suggested. The cosmos was not static, as once believed, but dynamic, stretching and evolving. Time and space were not eternal pillars, but living entities, changing as the universe breathed. This idea shook philosophy and religion alike. The universe had a beginning. Creation itself, it seemed, was no longer a matter of faith alone, but of physics. In laboratories and observatories, scientists began to find evidence of relativity everywhere. Atomic clocks showed that time truly ran slower at higher speeds. Cosmic rays and subatomic particles behaved exactly as Einstein's mathematics had predicted. Even the bending of light by galaxies, gravitational lensing, became a tool for peering into the depths of the universe. What had begun as thought experiments in a quiet room had now become the foundation for an entirely new way of exploring the cosmos. Yet Einstein, though proud, was restless. He admired the quantum pioneers who followed him, Planck, Bohr, Heisenberg, but their discoveries unsettled him. Their vision of a probabilistic universe seemed to clash with his belief in a cosmos of order and continuity. To Einstein, relativity and determinism were intertwined. Every event in spacetime, he believed, had its reason. The randomness of quantum theory felt like a betrayal of that harmony. And so, as the scientific world embraced quantum mechanics, Einstein pursued a different path, seeking a unified field theory that would reconcile all forces under one elegant framework. Decades passed, his hair grew wilder, his fame greater, but his focus remained unbroken. He filled notebooks with equations that sought to merge gravity with electromagnetism, the large with the small. He did not succeed, yet in his failure lay a profound truth: that even the greatest minds are humbled before the infinite. Einstein understood this better than anyone. The important thing is not to stop questioning. He wrote, "Curiosity has its own reason for existence." That belief, that eternal questioning, became his true legacy. Meanwhile, relativity began to shape the modern world in unexpected ways. Technologies that no one in Einstein's youth could have imagined now relied on his equations. GPS systems used by billions daily corrected their signals for the warping of time predicted by relativity. Satellites circling Earth moved through slightly weaker gravity than people on the ground, and thus, their clocks ticked faster, a difference Einstein had foreseen. Without those corrections, navigation would be impossible. Even the synchronization of power grids, communication networks, and astronomical measurements all quietly depend on his understanding of time and space. In this way, Einstein's theory became not only a pillar of science, but a silent companion in daily life, a reminder that even the most abstract ideas can shape the tangible world. The man who once questioned whether time was absolute had ended up redefining how humanity measures it. Every second, every orbit, every signal carries the fingerprint of relativity. The impact went beyond the technical. Relativity transformed the human imagination. It taught people to see motion, perspective, and existence itself as relative, to understand that truth depends on context, and that there is beauty in that complexity. It influenced architecture, where straight lines gave way to curves, psychology, where perception became central to understanding the mind, and literature, where nonlinear storytelling echoed the relativity of time. Einstein had not only given humanity a new universe, he had given it a new language to describe experience. And yet, behind this monumental shift stood a man who valued simplicity above all. In his later years, Einstein often spoke of feeling connected to something eternal, a cosmic order beyond human comprehension. He saw the universe not as a cold machine, but as a vast, interconnected whole, filled with wonder. His scientific method was rooted in intuition as much as logic. Imagination, he said, is more important than knowledge. for knowledge is limited, whereas imagination embraces the entire world. In those final decades, as he walked through the campus of Princeton University, students would often stop to watch him. His white hair untamed, his eyes distant, as if he were listening to some hidden rhythm in the air. He was no longer chasing fame or recognition. He was following the same invisible compass that had guided him since childhood, when a simple needle pointing north first awakened his sense of mystery. That same curiosity now drove him to seek the ultimate unification, the one equation that could describe everything, from the smallest atom to the grandest galaxy. Though he never found it, his journey itself became a beacon for generations to come. Scientists built upon his work, discovering black holes, gravitational waves, and the expanding universe he once envisioned. When, in 2015, the LIGO Observatory detected gravitational waves, ripples in spacetime created by colliding black holes, the world once again turned to Einstein's equations. His predictions, made a century earlier, were confirmed in exquisite detail. The universe had spoken in the language he had written. Even today, relativity remains one of the most thoroughly tested theories in science. Every experiment, every observation, reaffirms its precision. Yet what continues to inspire is not just its accuracy, but its poetry. The way it reveals a universe woven from light, time, and geometry. It tells us that gravity is not a force pulling us downward, but the gentle curvature of the cosmos guiding our path. It shows that time can slow, that light can bend, that reality itself is not fixed but alive. And within that living universe lies a message, one that Einstein understood better than anyone, that the pursuit of knowledge is not about control, but about connection. The more deeply we understand nature, the more we realize that we are part of it, that our thoughts, our discoveries, our questions are extensions of the same cosmic order we seek to describe. The theory of relativity, in the end, was never about equations alone. It was about vision, a vision of unity, humility, and wonder. Einstein once said, "Look deep into nature, and then you will understand everything better." He believed that the universe speaks through simplicity, through patterns of light, motion, and form. His relativity did not shatter the world's faith in order, it restored it, showing that even chaos has structure, and that beauty resides in truth. His discoveries transformed science, but his philosophy transformed the spirit of inquiry itself. When Einstein passed away in 1955, his body was laid to rest quietly, but his ideas continued to expand outward, like ripples in spacetime. Decades later, as satellites orbit Earth and telescopes capture light from the edge of time, his fingerprints remain everywhere. Every gravitational lens that reveals a hidden galaxy, every measurement of cosmic expansion, every whisper of a wave in spacetime carries his mark. The birth of relativity was not an event, it was a beginning, a spark that continues to illuminate the path of discovery. Perhaps the most remarkable thing about Einstein's theory of relativity is not what it tells us about the universe, but what it tells us about ourselves. It reminds us that perception shapes reality, that truth can be seen from infinite perspectives, and that our quest for understanding is what binds us to the cosmos. The same curiosity that drove Einstein to imagine riding a beam of light still drives humanity today as we peer deeper into the unknown, searching not for dominance but for meaning. And so, as the stars continue to move and time continues to stretch, Einstein's vision endures, not as a relic of the past, but as a living testament to human wonder. The theory of relativity is no longer just physics, it is philosophy, poetry, and prophecy combined. It speaks to the eternal dialogue between mind and universe, a reminder that to question is to live, and to imagine is to be infinite. The legacy of relativity is the legacy of curiosity itself. It began with a young man dreaming in silence, and it continues in every scientist, artist, and thinker who dares to look beyond the visible. Einstein's universe is still unfolding, a universe where time and space are not boundaries but invitations, calling humanity to explore, to create, and to understand. Through his vision, we discovered not only the structure of the cosmos, but the power of the human mind to grasp it. In the final light of reflection, the theory of relativity stands as one of humanity's greatest achievements, not because it changed how we see the universe, but because it reminded us that we can see it differently. Einstein unlocked the door to a deeper reality, and through it, we glimpsed infinity, vast, silent, and magnificent. The journey that began in his thoughts continues in ours, forever expanding, forever bending, forever relative. In the vast landscape of Einstein's intellectual journey, one of the most profound chapters lies in his relentless pursuit of unity. The dream of finding a single, elegant theory that could explain the entire universe. This quest was not born merely out of scientific ambition, but from a deep, almost spiritual belief that nature must be harmonious. To Einstein, the universe was not a collection of disconnected forces or random events. It was an intricate tapestry woven with purpose and symmetry. He believed that behind every mystery, no matter how complex, there existed an underlying simplicity waiting to be discovered. As the world celebrated him as the father of relativity, Einstein was already turning his attention beyond. His theories had redefined gravity, space, and time, yet he was unsatisfied. The universe, as he saw it, could not be truly understood until all of its forces were unified under one grand design. The problem was monumental. Gravity, electromagnetism, and later, the nuclear forces appeared vastly different in their behavior. But Einstein refused to believe that nature could be so fragmented. God does not play dice with the universe, he famously declared, rejecting the growing indeterminacy of quantum mechanics. His vision of science was deterministic, ordered, and complete. In the years that followed, he immersed himself in complex mathematics, searching for connections that might bridge the chasm between relativity and electromagnetism. Every morning, he would walk the same path through the streets of Princeton, lost in thought, his hair uncombed, his mind miles away. Colleagues often saw him sitting at his desk, surrounded by notebooks filled with symbols, lines, and equations. A man wrestling with the infinite. He sought beauty in the patterns of mathematics, convinced that when the final equation emerged, it would be not only correct but also elegant. However, as the 20th century progressed, science began moving in a direction Einstein could not follow. Quantum mechanics was revolutionizing physics, revealing a subatomic world where uncertainty ruled. Particles behaved like waves, probabilities replaced certainties, and the very act of observation seemed to shape reality. To many physicists, this was the dawn of a new era. But to Einstein, it felt incomplete, even chaotic. He respected its success but rejected its philosophical core. He could not accept a universe governed by chance. To him, true understanding required a deeper, deterministic order beneath the apparent randomness. Despite this tension, Einstein continued his solitary search for a unified field theory. Year after year, he refined his equations, hoping to merge gravity and electromagnetism into a single framework. Though progress was slow and often discouraging, he never gave up. Friends urged him to collaborate, to embrace the new quantum ideas, but he chose instead to trust his intuition, that nature's laws must ultimately fit together like pieces of a cosmic puzzle. He once said, "What I seek is simple, a theory so beautiful that it must be true." In his later years, Einstein's pursuit took on a more reflective, almost philosophical tone. He began to see his quest not merely as a scientific problem, but as a journey toward understanding existence itself. The unity he sought in the equations was, in a sense, the unity he felt between the human mind and the universe. He often spoke of the cosmic religious feeling, the awe and wonder that arise when one contemplates the mysterious order of creation. He believed that science at its best was an act of reverence, an attempt to read the mind of God. Though Einstein never completed his unified theory, his pursuit transformed the way humanity approached the idea of knowledge. He showed that the true spirit of discovery is not in the final answer, but in the eternal quest. His equations may have remained unfinished, but his vision inspired generations of scientists who carried his dream forward. those who later developed quantum field theory, string theory, and the search for a theory of everything. In many ways, Einstein's dream still lives, echoing in the laboratories and observatories of the modern world. Even near the end of his life, when fame and age had slowed his steps, Einstein's eyes still carried the same light of curiosity that guided him as a young man. He once said, "The important thing is not to stop questioning." For him, science was never a career. It was a calling. Each mystery he unraveled only led to deeper questions, and each discovery opened a new horizon. His quest for unity was not a failure. It was a testament to the boundless curiosity that defines the human spirit. Einstein's later years reveal something profound about his character. That true genius lies not in finding all the answers, but in daring to ask the questions no one else can imagine. His pursuit of a unified theory stands as a symbol of humanity's deepest desire: to find meaning, coherence, and beauty in the vastness of the cosmos. And though the final equation may remain hidden, his legacy reminds us that the universe is not a place of chaos but of wonder, a place waiting to be understood by those bold enough to seek its secrets. In the end, Einstein's lifelong search for unity transcended science. It became a reflection of his belief in harmony, not just in the laws of nature, but in the interconnectedness of all things. The same logic that governed the motion of planets, he believed, shaped the rhythm of life itself. To understand the universe, one must look not only through the lens of mathematics, but through the eyes of awe and imagination. Einstein's dream lives on, not merely in equations or theories, but in the hearts of all who look at the stars and wonder what lies beyond. As the 20th century unfolded, Albert Einstein became more than a scientist. He became a global symbol of intellect, curiosity, and moral courage. Yet behind the fame and the iconic image of the man with wild hair and kind eyes was a soul deeply connected to humanity. The fifth keynote in his story reveals not only the thinker who changed science, but also the man who spoke to the conscience of the world. Einstein understood that knowledge without wisdom was dangerous, and that progress without compassion could destroy the very civilization it aimed to improve. His voice carried beyond equations and experiments. It became a call for peace, freedom, and the ethical use of human power. In the years after his great scientific triumphs, Einstein watched as the world around him fell into turmoil. Wars erupted, ideologies clashed, and humanity stood divided by fear and greed. Having seen firsthand the destructive potential of science when guided by politics, he felt a moral responsibility to speak out. His equation, Etum and C dive, which once symbolized beauty and unity in nature, had been used to unlock the terrifying power of the atomic bomb. Though Einstein himself did not work on nuclear weapons, his ideas had paved the path that others followed. This realization weighed heavily on him. He later confessed, "Had I known that they would do this, I would have become a watchmaker." It was not guilt for discovery, but sorrow that his vision of light had been turned into darkness. Einstein's influence now extended beyond laboratories and universities. He used his fame as a platform to promote peace and disarmament, urging nations to rise above their rivalries. To him, science was meant to serve humanity, not to dominate it. He believed that true civilization required moral progress to match technological advancement. "The splitting of the atom has changed everything," he said, "except our way of thinking." Those words captured his deepest fear: that mankind's intelligence was evolving faster than its wisdom. He wanted people to remember that the universe, though governed by laws of physics, also demanded laws of conscience. In America, Einstein became an advocate for justice and equality. He spoke against racism, fascism, and oppression wherever he saw it. He refused to remain silent in the face of injustice, calling segregation America's worst disease. He supported civil rights leaders and lent his voice to the struggles of the oppressed. Despite his fame, he lived humbly, detached from wealth and comfort, and guided by moral clarity. He believed that compassion was not an act of charity, but a duty of understanding. The The same curiosity that drove him to study the cosmos also made him look deeply into the human heart. Einstein often described himself as a citizen of the world. He despised nationalism and war, seeing them as the primitive instincts of an immature species. His dream was of a united humanity, a global community where knowledge, peace, and cooperation replaced borders and hatred. He supported the establishment of international institutions that could prevent conflict and promote dialogue among nations. To him, the mind that could understand the curvature of space should also be able to understand the need for harmony among people. Despite his fame, Einstein remained remarkably humble. He avoided luxury, preferred simplicity, and often played his violin to calm his thoughts. He saw music as a bridge between the intellect and the soul, a form of harmony that mirrored the order of the universe. To those who met him, he appeared both deeply human and endlessly profound. A man who carried the weight of knowledge, yet never lost his sense of wonder. His laughter was soft, his words deliberate, his eyes filled with both wisdom and sadness, as though he saw beyond time itself. As he grew older, Einstein's reflections became more philosophical. He saw life as a brief moment of consciousness within the grand cosmic order, and yet he believed that every act of kindness, every pursuit of truth, contributed to the eternal beauty of existence. He spoke often about humility before the mysteries of creation, calling it the foundation of true religion and science alike. He rejected the notion of a personal God who intervened in human affairs, yet he deeply believed in a divine order, the cosmic religious feeling, as he called it, the awe that arises when one contemplates the perfection of the natural world. For Einstein, to understand the laws of the universe was to feel a kind of sacred connection to something far greater than oneself. His final years were quiet but never idle. Even as his body weakened, his mind remained alive with questions. He continued his pursuit of a unified theory, scribbling notes and equations until the very end. When he passed away in 1955, the world mourned not just a scientist, but a thinker who had touched the soul of humanity. His ideas had expanded our understanding of the universe, but his spirit had reminded us of our moral duty within it. Einstein's legacy endures not only in physics but in philosophy, ethics, and the collective conscience of mankind. He showed that genius is not measured by intellect alone, but by empathy, imagination, and courage. He proved that science and humanity are not separate, that understanding the stars is meaningless unless we also understand ourselves. Through his life, he left behind more than discoveries. He left a message that the true measure of civilization is not power, but compassion, not control over nature, but harmony with it. Einstein's greatest equation, perhaps, was not written in symbols, but in the way he lived, balancing knowledge with wisdom, reason with wonder, and intellect with an unshakable faith in the goodness of humanity. As the world moved deeper into the age of science and technology, Albert Einstein's influence extended far beyond the boundaries of physics. His sixth keynote lies in the transformation he inspired, the way his discoveries reshaped not only science, but the very way humanity perceives reality. Einstein had revealed that time could bend, that space could curve, and that energy and matter were two faces of the same coin. But perhaps his greatest gift was not a set of equations. It was a new way of seeing the universe. His work opened humanity's eyes to the infinite, to a cosmos alive with mystery, motion, and interconnection. Through his mind, the universe ceased to be a static clockwork and became a vast, dynamic symphony of forces and possibilities. The implications of Einstein's theories rippled through every branch of science. His relativity laid the foundation for understanding the expansion of the universe, the bending of light by gravity, and the behavior of time near massive stars and black holes. Without Einstein, modern cosmology would not exist. The discovery that space itself could stretch and that the universe was not eternal but evolving changed the story of creation. The Big Bang Theory, the concept of gravitational waves, and the study of black holes all owe their origins to his vision. He had transformed humanity's perception of the cosmos, turning the heavens from a fixed stage into an unfolding drama of space-time. In the world of technology, Einstein's equations became silent engines behind progress. Global positioning systems that guide travelers, satellites that orbit Earth, and even the understanding of nuclear energy are rooted in his insights. What once seemed theoretical became essential to daily life. Through his genius, Einstein had stitched his ideas into the fabric of modern civilization. The universe he described was no longer distant. It pulsed through every device, every clock, every corner of the world, connected by invisible signals and waves. Yet, the influence of Einstein's mind reached beyond science and technology. Artists, philosophers, and writers found inspiration in his concepts. Painters saw in relativity a metaphor for perspective and dimension. Poets found in it the language of connection, and philosophers used it to rethink truth itself. The notion that time and space were relative challenged long-held beliefs about certainty and reality. Einstein had not just rewritten physics, he had redefined how humanity thinks. He showed that knowledge is not fixed but evolving, that truth depends on the observer, and that curiosity is the force that moves civilization forward. Einstein's way of thinking became a model for creativity. He valued imagination even above knowledge, calling it the seed of discovery. Imagination, he said, is more important than knowledge, for knowledge is limited. This belief transformed education, inspiring generations of thinkers to question rather than memorize, to explore rather than conform. He taught that science was not a list of facts, but a living adventure, a continuous conversation between the mind and the universe. His thought experiments, his ability to visualize unseen realities became legendary. In a world often dominated by routine, Einstein's thinking reminded humanity that progress is born from wonder. He also reshaped the relationship between science and spirituality. Einstein's universe was not cold or mechanical, it was full of order and mystery. Though he rejected dogma, he often spoke of a cosmic religious feeling, a sense of reverence before the laws of nature. To him, discovering the secrets of the universe was a sacred act, an encounter with something eternal. His view bridged the gap between reason and faith, showing that awe and logic are not enemies but partners in the search for truth. He believed that the beauty of nature's design was itself proof of something profound, a harmony that transcended human comprehension. Even decades after his death, Einstein's ideas continued to evolve through others. Scientists expanded his theories, testing them in ways he could only imagine, measuring gravitational waves, capturing images of black holes, and exploring the farthest reaches of the cosmos. Each new discovery echoed his vision, confirming that his understanding of the universe was not just correct but prophetic. He had seen farther than anyone of his time, and his legacy became the compass for those who followed. But Einstein's influence cannot be measured only by scientific progress. His name became a synonym for genius, but his genius was never detached from humanity. He stood for curiosity, humility, and moral responsibility, qualities that defined him as much as his intellect. In a century marked by conflict and division, he reminded the world that the pursuit of knowledge must always serve peace. He believed that science without conscience was a threat, and that wisdom lay in understanding both the power and the limits of human reason. The world today still moves under Einstein's shadow, from the smartphones in our hands to the telescopes that peer into distant galaxies. His theories remain alive, guiding our understanding of everything from subatomic particles to the birth of time itself. But beyond the physics and technology, Einstein's enduring lesson is philosophical, that reality is more mysterious than we imagine, that truth is revealed through curiosity, and that knowledge must always be tempered with compassion. In the end, Einstein's greatest legacy was not just in what he discovered but in what he inspired. He showed that even one mind, guided by wonder and courage, can reshape the universe for all of humanity. His story reminds us that the pursuit of truth is never complete, that each generation must continue the search, question the unknown, and look at the cosmos with the same awe that once filled the heart of a young boy staring at a compass needle, realizing that something invisible, yet profoundly real, moves the world. As the curtain of life slowly drew toward its final act, Albert Einstein stood not just as a scientist, but as a timeless thinker whose vision transcended generations. The seventh keynote in his legacy is about immortality, not of the body, but of the mind, the spirit, and the influence that endures long after death. Einstein's life became a mirror through which humanity could see its own potential. He had unlocked the deepest laws of the cosmos, yet he never claimed mastery over them. He had stood face to face with the infinite, yet remained humble before its mystery. To the end, he embodied the idea that true greatness lies not in power or fame, but in curiosity, compassion, and the unending pursuit of truth. Even in his later years, Einstein's spirit was undiminished. His hair had turned silver, his face lined with age, yet his mind continued to roam the universe with the same youthful wonder that had once imagined riding on a beam of light. He often spoke of the beauty of simplicity, believing that understanding nature was like listening to a divine symphony, one that revealed itself only to those who observed with patience and awe. His office at Princeton was cluttered with papers, notebooks, and letters, but amid the disorder was a quiet focus. Visitors would find him lost in thought, sketching equations that danced between science and philosophy. Though his health weakened, his passion for discovery remained eternal. He rejected fame, never seeking to be worshipped. To him, celebrity was meaningless, a distraction from what truly mattered. He declined political positions, refused luxury, and chose a modest life filled with books, music, and reflection. When asked about the secret to his genius, he simply smiled and said that he had no special talents, only a passionate curiosity. In those words lay the essence of his immortality. Einstein had taught the world that genius is not a gift reserved for the few, but a flame that burns in anyone who dares to question, to dream, and to seek understanding. In his final days, Einstein worked quietly on his unfinished dream, the unified field theory. Even as his body grew frail, he continued to write, his handwriting shaking but his thoughts steady. It was as though he knew his time was short, but wanted to leave behind one last message to the cosmos he so deeply loved. When he passed away in 1955, he left not only scientific papers and ideas, but a legacy of spirit, a reminder that the human mind is capable of touching eternity. His brain was later studied, but the true source of his brilliance was never found under a microscope, for it resided not in the folds of tissue, but in the vastness of his imagination. After his death, Einstein became more than a historical figure. He became a symbol. His name came to represent curiosity itself, a universal language of wonder that transcended borders and beliefs. Scientists continued his quest, artists painted his image, and philosophers quoted his words. He had become part of human culture, a bridge between science and humanity, intellect and soul. The theories he left behind continued to shape the future, from black hole discoveries to the birth of quantum technology, proving that even after death, his mind was still alive in the progress of civilization. But Einstein's immortality lies not only in science. It lives in the values he stood for: humility, peace, and the pursuit of wisdom. In an age driven by conflict and ambition, he reminded the world that knowledge must be guided by morality. He saw science as a servant of humanity, not its master. Only a life lived for others is a life worthwhile, he said, and he lived by those words. His kindness, his humor, and his deep respect for life made him more than a genius. They made him a moral compass in an age of uncertainty. Einstein's philosophy of life remains as relevant as his physics. He believed that education should awaken curiosity, not suppress it, that creativity was the heart of learning, and that imagination was the key to progress. He inspired generations to think freely, to question authority, and to see knowledge not as a collection of facts, but as a way of touching the infinite. For him, the greatest joy was in the mystery, in knowing that the more we learn, the more there is to discover. His was a vision of endless exploration, a universe without walls. Decades after his death, Einstein's ideas continue to guide humanity into the future. From the exploration of outer space to the quest for understanding consciousness itself, his spirit echoes in every great scientific endeavor. The black holes that bend light, the gravitational waves that ripple through space-time, the technologies that connect the world, all bear his signature. Yet beyond the science, his words remind us of something even more profound, that the universe is not a place of chaos but of harmony, and that by understanding it, we also understand ourselves. In the quiet hours of reflection, one can imagine Einstein still gazing at the stars, his mind traversing the cosmos he once described. His laughter, his violin, his simple walk through Princeton's streets, all have faded into memory, but his essence remains. He proved that a single mind, guided by curiosity and compassion, can change the destiny of humankind. His life became a message that the search for truth is endless, that wonder is sacred, and that even in an infinite universe, one life, lived with purpose, can illuminate eternity. Albert Einstein did not simply explain the universe. He became a part of it. His ideas flow through the galaxies, his vision shapes the tools of discovery, and his wisdom continues to awaken hearts and minds. Time may move forward, stars may fade, but Einstein's light remains, woven forever into the fabric of existence. A reminder that the human spirit, when guided by imagination and love for truth, is itself immortal.